Welcome to episode 8 of Generating Conversations. If you're new to our podcast, we're inviting experts in LLM technology from research and industry to talk about big ideas and trends that are shaping the field. In previous episodes, we discussed the future of open source models, tool use, and where reinforcement learning is headed. Today, I'm really excited to have Ajay Jain, the co-founder of Genmo, a generative AI startup that allows users to intuitively synthesize video and other creative assets through an interactive web experience. Ajay did his PhD at UC Berkeley in AI systems and generative AI. Ajay pioneered the application of diffusion models for image generation, as well as 3D modeling, and he built Genmo along with his brother Paras, who was my former PhD student. So I'm excited to have you here today. Welcome, Ajay.
Oh, it's wonderful to be here today. Thanks for having me on the podcast.
All right, well, let's start with how does diffusion model work? You were one of the pioneers in diffusion models for image generation. Tell the audience how a diffusion model works.
A diffusion model is a really interesting type of generative model. In some ways, it aligns with how humans think about synthesis. In other ways, it's completely otherworldly. So you can imagine a diffusion model as two coupled processes. One takes data, let's say an image. An image can be thought of as a vector with some high dimensionality. If it's a 32 by 32 pixel image, black and white, that would have 32 times 32, 1024 dimensions in it. So it's a 1024 dimensional floating point vector representing your image. This image data follows certain patterns. It has smoothly changing gradients. It may have a certain color distribution. Content in that follows certain shapes. It's hard to directly generate that content. But what's really easy for a model to do is to corrupt that vector by adding noise to it. You can imagine different corruptions like blurring, adding noise, masking. What we call this in the diffusion model literature is the forward process that takes data like an image and gradually adds noise to it. Little bits until you get to a known prior distribution. If you add enough noise to your image, you eventually get just noise with very little signal left in it. The job of the learning component of a diffusion model is to learn how to reverse this forward process. That's called the reverse process, and what it does is iteratively adds back some of that signal that you removed from the image. This is done by learning on a data set of images, what patterns are present, and then learning how to denoise with a neural network, such as a U-net architecture, which is a hybrid between a transformer and a convolutional neural network.
That's a great explanation. When I think about it, it's exactly that. It's you've taught a model to take something that's noisy and just fix it, but a little bit at a time. And that kind of incremental refinement of an image that's mostly noise, but I think I see an eye, and I've given an instruction that this image should have a face in it. Maybe that is the eye. And the model works through this process. We've taught it how to fix this small amounts of corruption to get to a final high quality image. And it's pretty neat. Your idea, this diffusion technique for generating images, has been used in a lot of areas now too, from not just images to 3-dimensional models, and you've been doing work in that space, which we'll get to in a moment. My group started to borrow that idea for how to generate molecules in the design of molecules for drug design and for carbon capture. So a lot of opportunity for using this idea of how to take something, break it, and then fix it slowly. And I guess diffusion itself actually predates the work that you've explored in image generation, but you guys really kind of cleaned it up for the computer vision and actually for the machine learning community as a whole, and widely popularized it.
Yeah, absolutely. So this idea of a diffusion model is a little older than when we got to it. It was proposed by Joshua Soldikstein, who's a research scientist at Google. At the time, I think he was at Stanford. He also spent some time at Berkeley. That paper was published in 2015 called Deep Unsupervised Learning with Non-Equilibrium Thermodynamics, and took some physically inspired principles in its motivation. At its core, that model is actually was phrased in a lot of the same math as the variational autoencoder, a VAE, which is even older technique and has roots in Bayesian inference, Bayesian deep learning. The diffusion model, when we started working on it, was attractive to me from the systems perspective, actually. I had just spent a lot of time working on GPT-like models in the first year of my PhD, but trying to apply GPT-like models to images, where you would take an image and instead of generating one token at a time, one word at a time, the model would learn how to generate one pixel at a time. Raster scanning over the image, generating one row. Now, this works for small images just fine. It actually was state of the art until recently in some benchmarks, particularly for compression. However, the problem emerges when you try to scale up to high resolutions. Very quickly, you get tens of thousands, hundreds of thousands, millions of dimensions, and that becomes an unscalable approach. Secondly, the model actually has a compounding error where there's these GPT style or pixel CNN style models overall degrade as the sequence length increases too much. A diffusion model is attractive because while it adds back structure into the image, it actually adds back that structure in parallel across the entire image in all regions. It gradually is adding detail everywhere. And that's compelling because from the system side, it can be parallelized effectively. From the machine learning side, you might be able to reduce this compounding error problem.
Excellent. And now, having talked about the basis for diffusion and, basic image generation and some of the history behind it, let's talk about what you're doing with Genmo. Tell us a little bit more about Genmo.
I can give a little bit of background on Genmo. Genmo is a startup we made in December, first line of code committed on Christmas 2022. Genmo is an AI studio where we develop some cutting edge visual generative models based on our foundational work in diffusion. Um, we offer products that allow you to generate videos, high fidelity AI videos from text, generate 3D objects, assets like meshes that you can put into your games and experiences, and images, all unified with a multimodal large language model infrastructure that makes it very intuitive to use the platform.
So I remember in the beginning when Paras and you were telling me about what you're doing with the generative AI work, and we were working on three-dimensional models, and Paras was also working on the systems for scaling training. Back then, when you were thinking about this stuff, what kind of was your motivation for Genmo?
I think it's been culminating for a long time. I really had a passion for creating products that were newly possible with AI. I mean, part of the reason I went and did my PhD was this sense that a lot of technology wasn't there yet. We had pretty big gaps in our capabilities to synthesize content in particular, both from the system side, these models are very expensive, and from the AI side. We didn't necessarily have the most scalable, stable architectures to synthesize high fidelity content. But that started to change, especially accelerating last year. There were some turning points in the PhD. One of them was we released this paper called Dream Fusion, the first text to 3D model that could produce high fidelity content. That was a research project, but it really caught the community by storm. We were pinned to the top of Hacker News for 24 or 36 hours. We got thousands of comments, many YouTube videos commenting on it, and just tons of people wanting access to the technology. But it was a project which we couldn't really release to the public for a couple of different reasons. I started to get the sense that now was the time to get visual synthesis technology out into the community because people were ready to adopt and the technology was getting mature.
Yeah, it makes sense. I recall actually, discussing with your brother Paras, kind of where all of this generative content was going. Specifically, you guys had done that really neat work on generating these three-dimensional models from images. I guess for our audience, you guys have been doing the foundation work in generative AI and image generation for a long time, including some of the early work in diffusion. I know back then there was some excitement around building three-dimensional models and being able to use generative AI to create assets for VR 3D content. Do you see that as something you'll be doing more of in the future? Or?
3D is a really exciting area. I mean, we people exist in a three-dimensional world. It's very intuitive to us. I mean, some of these notions of 3D consistency that are hard for a computer to learn are just built in. I mean, if you observe an object, you kind of have an intuitive sense of what it might look like if they turn around. That allows us to actually interact in the world without even our eyes open. A lot of the time, you get one glimpse and then you can kind of do actually complicated tasks like open a door with your eyes closed afterward. So that's really built into people. And what has been surprising is how hard it is to get computers to synthesize high fidelity 3D content. That said, I think it's still early in the 3D market. Um, Despite being so ubiquitous, we don't have that many widely used platforms where people are creating and sharing 3D content. Part of this is a chicken and egg situation where I think one of the blockers to wide scale adoption of virtual reality is this question of where are the compelling experiences. We can create more compelling experiences if there was better technology and tooling to be able to create 3D content. At the same time, until those platforms really grow and get mass scale adoption, it's a little tricky to create a tool if there's not the audience. So I think it's definitely an area of interest for us, but we're kind of watching how the market evolves for 3D synthesis. In the meantime, we are building high fidelity 3D geometrically controllable video models where you can actually grab the virtual AI camera and control it in 3D, roll the camera, rotate the camera, pan it, but you get out a video that you can go and share on TikTok, on marketing campaigns, on your website, with your friends, anywhere where there are really large audiences already.
Yeah, the stuff you guys are doing now is super cool, and it's really crisp too. It's come a long way. I'm guessing you can't share all the details behind it, but how are you doing that?
um, a lot of it is really careful analysis of where the artifacts come from. It's great to hear that you like the quality. So let me give a little bit of context. We recently released a model called Genmo Replay. Replay has been a labor of love for our team. We have been working on it quietly for a few months. We were one of the first companies to release, I think the first company to release an image animation product where you could upload an image, type a text caption, and animate it. And that's what we launched with in January. It got very popular. At the same time, that image animation model didn't have so much geometric coherence. So you could animate a person transforming through the years, aging up from a child to an adult, but it wouldn't actually necessarily preserve the exact shape of their face, their identity, things like that. So that's one thing our users wanted, and that's why we built Replay. Replay is the Dolly 2, Dolly 3 of video, where you can put in a text caption and generate a high fidelity short video clip. There's a ton of stuff that helps improve the quality. One of them is really a focus on resolution and smoothness in the model, where we want to make sure that the model is tuned for coherence over time. And so we have 30 FPS results at 720 or 1080p resolution.
Cool. Can you show us a quick demo of what you've been doing?
Absolutely. Let me show you some examples of what Replay can do.
Yeah, it's definitely it's cool. When I saw your latest releases, it blew my mind. People should definitely check it out. Yeah, and I guess you've noticed that a lot of stuff in the field's been heating up. I guess this week there's announcements. GPT v4, Dolly 3 is coming out. You all are a little different. That you're not just building the models. You're kind of thinking the tooling around how these pieces are put together. Maybe you can talk a little about what you're doing there.
We, from the beginning, really wanted to get the products we build out into people's hands. It was one of the motivations for starting Genmo, the sense that even though technology was accelerating, the product side was lagging. Often a year, 2 years before something was demonstrated in the lab to when people could get their hands on it. And so we really focus on usable interfaces that give you access to the powerful technology. We have a vibrant community creating videos, images, and 3D assets with Genmo through a couple of different product interfaces. We have two main interfaces to create with Genmo. The first is genmo.ai, where you can log in, text box right on the homepage, type in your query, just like it's google.com, but you generate videos out. And so the focus there is on speed and usability. Our second product is called Genmo Chat. And Genmo Chat is also accessible on the website. It is the chat GPT of visual synthesis. it is a multimodal language modeling product where you can upload images, type text, but you also get images generated, videos generated, and 3D objects. GPT Vision just got released recently, and it's in a similar spirit, where it augments people with both the language modeling capabilities of analyzing information and synthesizing information, as well as analyzing and synthesizing imagery. We do have a focus on multimodality, especially rich modality, in particular videos, and that's a unique capability I haven't seen out yet.
Yeah, I've been very impressed, and you guys were early to bring this kind of chat experience, and I think the way you've done it, which combines a bunch of models, kind of tool use in a really neat way. In fact, when we were designing the logo for this podcast, I turned to your tool to make the logo. It was really helpful, and it was a brainstorming session with an AI. It's neat. Can you maybe briefly talk about how you bring the tools in?
We interoperate a lot of different things in order to make Genmo chat possible. Um, so at its core, we need a strong language model foundation that can reason over its inputs. And the main way we implement Genmo chat is via tool use interface. So you can actually go onto when you go onto Genmo chat, you can see exactly what the agent is doing. We just show these little blue expandable chips, which you can click on and then see what different tools the agent is using. Genmo can call these different synthesis tools, such as generating images, generating videos, and generating 3D assets. We also incorporate some editing tools in there. It is a very difficult problem, though, today. And I don't think that language modeling technology is yet at a stage where you can reliably expect an LLM to be able to do any multimedia transformation that you might ask for. That is a problem that we run into at Genmo, and I think any LLM agent startup is likely to face at some point. It's a question of robustness and actually delivering on the promise of chat technology.
Yeah, you and your brother are, I guess, some of the thought leaders in both aspects, like design of models. You built the early diffusion, you did the early diffusion work. Your brother worked on a lot of the large scale systems for AI in the lab. In some sense, you two should be the strongest at solving many of these problems. And I'm guessing you've encountered a lot of problems. For two experts working together, what are the problems that you encountered that others should be starting to think about if they're working in generative AI?
There's really both product and AI questions here. On the product side, there's a question of what is the right interface to access synthesis and editing capabilities? Should synthesis and editing be combined into the same umbrella, or are they really disentangled products with different user modalities? Um, there are research questions here of how do we improve the robustness and reduce the hallucinations involved in tool use language models. That's a major problem area, but also a huge opportunity. Is if you can improve the robustness of tool use agents, then it unlocks a ton of business value, a ton of new product areas where you can connect LLMs to the real world. And Joey, you and your lab do some of the new work in this area in robustifying API calling and tool use agents like Gorilla. So I think you're pushing on the frontier there.
Thanks. Yeah, it's an area that's it's been fun. Even with Gorilla, we're learning a lot and making a lot of mistakes along the way too. But it's I think it's where the field's going to head. Being able to use tools, and you guys were again at the forefront of doing that in creative AI. And then as you said, bringing the product in along with the technology to make that a clean experience. One of the things that we've struggled with, in research, and I'm curious how you deal with this, is data. How do you get to data loops? How do you bootstrap when you're a small startup?
You have to get creative. So in terms of data, there's multiple types. There's feedback data, there's alignment data, there's also base pre-training data. We get very far with limited resources as a startup, I think. And so sometimes we need to be opinionated about capabilities we support. So in particular with our video model, for example, we focused on photorealism. That means that while it's great at realistic kinds of scenes, it still has opportunities for improving on animation styles and for longer videos where we focus on shorter videos. That's one response as a company, is to narrow your focus a little bit. At the same time, we know that for foundation model training, it is very important for the model to have a broad base of knowledge. So we can be really careful at training time. If the model has acquired some large set of knowledge, general purpose knowledge, how do we preserve that content in the model as we expand its capability set? Since it's very easy to forget certain knowledge or cover up certain capabilities in a model during fine tuning. So I think there's no one size fits all solution here.
Really cool. So maybe now let's talk about what your users are doing. I know you guys get to see really cool stuff, and I'm sure you work with some of your early users to help them, solve problems. Yeah, talk us through kind of the things that you see people doing that are, neat, would surprise us.
There's a ton of surprising things. I mean, we learn every day from our users when they create content, when they share it with the community, and when we talk to them for feedback. There's a lot of obvious and non-obvious ones. One of the um, business relevant use cases that actually turns out to be kind of popular is for marketing. So people like using our tools to animate product images, for example. For our initial alpha product, which we launched in January, we could upload an image and animate, especially background effects. People would use it for things like perfume advertisements, fashion ads. These often would end up on social media. We also have users who use it for personal pictures, and that was something we didn't really expect because the model was tuned for aesthetics and tuned for really stylized types of videos. So people would upload their personal photos or photos of their families and do things like see how their child will age up and things like that. Our chat copilot has been used in a lot of different ways. There's one film director we work with in Taiwan who has used it for storyboarding. So you can kind of talk to the agent about, say, oh, okay, I'm going to do this ad for a fitness brand. He was showing us this example, generating different panels. He said, okay, can I see that from the back, see that from another perspective? And some of the 3D tools came into play at that point. From there, we learned that there were actually a lot of use cases where people would be interoperating between different modalities. The text, brainstorming the script for the storyboard, generating image panels in a sketch style, turning them into video drafts, and then doing 3D novel view synthesis. It was interesting in particular in some of those cases because even if those assets, like the sketches, didn't make it into production, they were still useful for the creator to explore their ideas or share those ideas with different clients. Lastly, there's just a huge contingent of people who are using Genmo for fun, and we love that. We very much support it. I think people around the world are connecting deeply with AI, being able to intuitively understand how it can help them in their lives, how it can at least help them have fun in their lives. And so folks use it to do things like play games and chat with and Copilot, but enrich their experience with visual media. Finally, replay is very new. We have just 2-3 weeks under our belt with a new replay text to video model. And so we're exploring a lot of those use cases. Around the world, our community has been creating incredible things. Massive amounts of video. Our GPU servers have been super busy and have been so far been creating social content to share with each other online, on TikTok, on Twitter, and various platforms. We just ran a little challenge for visualizing the first interaction between aliens and humans and got a set of community contributions in that line that were fun.
So maybe let's wrap up with the kind of the looking forward. So where do you see the whole field of generative AI heading, and certainly in the kind of visual creative domain?
There's a long way to go before we hit reality, at least in terms of capability. Not necessarily in terms of timeline, things are accelerating quite a lot. Reality sets just such a high bar for visual generative researchers and companies. We are very used to real-time, high-fidelity synthesis all around us in geometrically consistent ways. At the same time, with the right tools, creators are able to go beyond reality and create things that don't exist, could never exist, aren't plausible. So what I would say for visual generative media is there's one line of work which is getting closer and closer to high-fidelity, fast reality synthesis, the virtual camera that can stream high-fidelity content in real time. There's both systems and machine learning challenges to addressing that problem. There's another line which is around enabling new experiences. So kind of transformative technologies, rethinking the control mechanisms people can have onto their models. The computer vision community is doing a great job here. There's been a lot of innovations in controlling diffusion models since our 2020 paper. With these effects, we actually integrated some of them into Genmo Replay recently with a product called Genmo Replay FX, where you can transform a video into a mesmerizing style. Like, for example, by putting a heartbeat overlaid onto your video, but it actually like enmeshes closely with the content. There's still a lot of outstanding questions around how we can improve the interoperability of different types of modalities. For example, how can we seamlessly transition from an image to 3D in high fidelity? When you do these transitions between modalities, generally there's some loss of information. Some details might not be preserved because different models might represent content in a different way. So that's an outstanding research question as well.
Yeah, it's really cool. I'm hoping to get students thinking about this stuff at some point in the near future too. There's certainly a lot of open research, but it sounds like what you guys are doing and others will bring us to, feature-length films that might be very realistic or very not realistic, but, fundamentally unique from what we've seen before. And, it sounds like that might happen in the next year or two at this rate. So, the world's moving very fast.
I was just saying we're working with one creator collective that is making a remake of a parody film of Terminator 2 with a large distributed collective of 50 creators. And so, maybe feature-length films will come out, maybe they won't. We will see what the results are like. That provides perhaps a benchmark for the community.
That's crazy and scary that Terminator is going to be our first, use of extreme AI to make a feature-length film. Wow. All right, well, let's end with that. Ajay, it's been great having you, and hopefully I look forward, seeing what you guys do in the future. Thank you.
Thank you, Joey.